Today we're going to look at congruent triangle postulates. These allow us to prove that triangles are congruent much faster than by definition. To use the definition, we have to prove 3 pairs of angles are congruent and 3 pairs of sides are congruent. For this, we need less. We only need 3 things instead of 6 things. The first one is the side-side-side congruence postulate. Now, that's a lot to write, and so typically we'll just abbreviate that by writing SSS. But we won't say SSS, we'll say side-side-side. Okay? In adult world, you don't say abbreviations. In texting world, you frequently say abbreviations like LOL and the like, right? But in adult world, they don't do that. They say what they stand for, okay? So, if the 3 sides of one triangle are congruent to the 3 sides of another triangle, then the triangles are congruent. In other words, if all the sides are the same size, well, then the angles take care of themselves. So here, since these 3 sides are congruent to these 3 sides from one triangle to the other, the 2 triangles are congruent by side-side-side. Remember that when I'm naming them, if I name the first one FAR, I've got to make the second one match up. So I said FA was my first side. Side FA is congruent to side OU, so OU has to be the first side of this one. Right? You've got to make the corresponding parts match up when you name the 2 triangles. We're not to the place where you're going to have to yet, but that's coming. All right, we also have 2 other ones. The side angle side congruence postulate, abbreviated SAS, says that if you have 2 sides and their included angle of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So what do they mean by the included angle? Well, if I have this side and this side, do you see how that angle is in between them? That's the included angle. So here I've got 2 sides and an included angle congruent to the corresponding parts over here, where I've got 2 sides and the angle that's included in between them are congruent to each other. Then those 2 triangles are congruent by side angle side. Now you have to be careful. Take, for example, this picture. This has 2 pairs of congruent sides and 1 pair of congruent angles, but is this angle included in between those 2 sides? No. And that's why it's called side angle side, is because the angle is between the 2 sides. It wasn't just random that somebody made it up to try and, be mean to 10th graders, right? That's not what it's about. So here, this is not side angle side. This isn't anything. You can't prove these congruent by side angle side because this angle is not between the 2 sides. All right, and then the last postulate, and we'll learn a couple of other shortcuts, I think starting tomorrow, is angle side angle. So there's side angle side and angle side angle. With angle side angle, you need 2 angles and the included side, that is the side that runs between those 2 angles, congruent to 2 angles and the included side of the other triangle, then those triangles are congruent by angle side angle. All right, so what kind of problems are you going to have to be able to do with these? Well, one type is this. It'll say something like this: decide whether you can conclude that the triangles shown are congruent. If so, name the postulate used and write a congruence statement. Now, a congruence statement is just where you say triangle ABC is congruent to triangle XYZ. And that's so you can practice making the corresponding parts match up, because that's going to be really important to us. So, hang on just a second. On tonight's homework, all it asks is, can they be proved congruent? And if so, give the postulate. This says, give the postulate and then write the congruent statement. So the instructions are a little bit different. So, read and follow instructions. So for example, this one. Right now, I only have 2 pair of congruent things. I've got a pair of congruent angles and a pair of congruent sides. That's never going to be enough because it's only 2 things. It's always got to be at least 3. But what else do we know about this where these 2 triangles are stuck together on this one side? What can we add? Not reflective, but see if you can get the right word. No. She was very close. She just was, it's reflexive property, not reflective. It's not shiny. Okay, it's not a mirror, but the reflexive property. And it actually, I always think it's pretty easy to remember because we mark it with an X. So it's the reflexive property, not the reflective property. Yes? You would lose points because it's the wrong word. Yeah, I'm not hard on spelling because I wasn't very good at spelling when I was your age. But if you spell a different word, then I'm all over it. Okay? Did you have a question?
How do you spell that?
Reflexive? Yeah. Just like a reflex action. Now notice what we have. In this triangle, we've got 2 sides and the angle that's in between them. We always have to check that we have the same thing on the other side. We've got 2 sides that have been marked and the angle between them. This is side, angle, side. The congruence statement, which you're not going to have to do on at least the first part of tonight's homework, you can name the first triangle anything you want. I'm going to call it ABD. But then for the second part, you have to make it match up. So what does AB in this triangle match up with in the second triangle? CB. So this is CBD. So that all the corresponding parts match up. All right, let's look at number 2. Here we've got 3 things, but only 2 are marked congruent. But what do we know about all right angles?
They're 90 degrees.
Yeah, and therefore they are? One word.
Complementary.
No, they're not complementary.
Right triangle.
Pardon?
Right triangle.
No. Hopefully you wrote this at least once or twice on your homework. All right angles are congruent.
Oh dear.
So, now let's look at what we have. On the triangle on the left, we've got 2 angles that are congruent. And is this the side in between them? Is this side between those 2 angles? Yeah, it runs from one angle to the other. Is it the same way on the other one? Always check to make sure it's the same on both of them. It is. So this is side, angle, side. Oh, excuse me. I apologize. It's angle, side, angle. because it's two angles and the side that runs in between them. Again, you can name the first one any way you want. I'm going to call it KLJ. And you just have to make the corresponding parts match up. What does K match up with in the other triangle? T. And L matches up with N, and that means that the last one's got to be N. M. All right, let's try these two. For number 3, again, we have one pair of congruent angles and one pair of congruent sides. That's two things. That's not enough. So you have to look for something else that you know is true. What else do you know is true in this diagram? Yes, ma'am.
Vertical angles are always congruent.
Exactly right. Perfect. These vertical angles are congruent to one another.
And then the other two.
Well, no, this is all we need.
Oh, okay.
We have enough. Now you can go on, but this is all we need. Because how many pairs of congruent angles do we have? We have 2 pair of congruent angles and 1 pair of congruent sides. Is the side in between the 2 angles?
Yes.
Yes. So that's angle, side, angle. Because this side right here goes in between these 2 congruent angles. And over here, this side goes in between these 2 congruent angles. So then if I call the first one triangle LUP, again, the first one, call it whatever you want. But then you just got to make the parts match up. What does L match up with in the other triangle?
That's a T.
T. How do you know it matches up with T and not S?
Because it flips.
Because they're what?
Because the line going through you. The line
Because
going
it
through
says
you
that
flips.
Yeah, this arc says angle L is congruent to angle T. Yeah. And then U in this triangle matches up with, well, U in the other triangle, so that's got to be TUS. Yes, ma'am.
Was there a congruent statement for number 2?
Did I leave it off? Yeah, it's there. Yeah. All right, on number 4, they only told you 1 pair of things are congruent, so you have a little more work to do here. What else can we add in this diagram? Yes, ma'am.
This might be a long shot.
It's okay.
but, since they have parallel lines, you would have like an alternate interior angle.
So which ones?
The ones obviously inside.
So name them.
E L. Is that a V?
This is a V.
E L. No. E V L and O L V.
Yes. EVL and OLV. Because we have these parallel lines, those alternate interior angles are congruent. So now I have 2 pairs of things that are congruent. That's still not enough. What else do we know? Give you a hint, look back at the first one. Yes, ma'am.
Since would that be a is it that line? The L.
We don't know that it bisects anything. No, because we would need to know that the left and the right sides were parallel to say that. So what about the reflexive property? What would it tell me?
That middle line.
That middle line. He has a name, let's call him by his name, not hey you.
LV is congruent to LV.
Yes. LV is congruent to LV by the reflexive property. Now let's look at what we have. In this triangle, we've got one angle congruent to this other one, and two sides that are congruent to the other triangle. So two sides and an angle. Is the angle between the two sides? Yes. And on the second triangle, is the angle that's marked congruent in between the two sides? Yes. So that's side, angle, side.
Get it, Mr. Davis.
That's why it's called side, angle, side. And let's say I named the first triangle LVO.
Wait, do we get a worksheet?
For tonight's assignment? Yeah, it's a worksheet. You guys, you could look at the, calendar or RenWeb. All right. So L in this triangle matches up with what in the other triangle? L in the top triangle matches up with V in the bottom triangle. V in the bottom triangle matches up with L. And O in the first triangle matches up with E. Okay? All right, let's go to the last page. Here we're going to fill in the missing pieces. Before this unit is over, I will expect you to be able to write this from nothing.
Oh, that's great.
Okay? For now, we're going to help you along a little bit, but we'll slowly but surely take that away. Okay? So, here it says that AR bisects the angle DRT and DR is congruent to segment TR. How do I know that's true? Because it was given. If you don't get that, I'm really worried about you. Then it tells me that angle DAR, D to A to R. If you're not sure what angle that is, trace it. D to A to R. Oh, that's this angle right here. Is congruent to angle TAR. That's this angle over here. I can't just say they're congruent because it would be nice if they were. But notice what we have here. AR bisects DRT. Hang on just a second. I'm going to have to change this because that doesn't match. Let's make it DAT so that it matches. Because if I bisect DAT, the two congruent angles should be up here at A. They should have the vertex up here. I switched them. I apologize. It told me I had an angle bisector. Okay, so that's the definition of angle bisector. Oh, and if I make that change, crud, I should have changed this instead. I'm going to have to change this. Let's make that DA and TA. Again, I apologize. I didn't realize that that was wrong. DA is congruent to TA. What are we going to say that segment AR is congruent to? AR. By the reflexive property. Exactly. And then which of our shortcuts are we using to prove triangle DAR congruent to TAR? Well, look at just one triangle. How many angles do we have that have been marked congruent? One. There's one pair, right? What about sides? There's two pair. Where is the angle relative to the two sides? It's in the middle, right? Side angle side. That clicking now? It takes a little while. All right, let's try this one. This one's got more holes in it. It's got a lot of given information. That's all, I put it all in the first statement. So it says I've got perpendicular lines. What do perpendicular lines do?
Right, sorry.
Yeah, they make right angles. So OB perpendicular to BT, where they meet is at B. That's going to be a right angle. And also at T. Boy, there's all kinds of mistakes in this. Angle B and angle T are right angles. How do I know that? Well, that's the definition of perpendicular lines. If I've got perpendicular lines, they're going to make right angles. Then it says, well, angle B is congruent to something. What is it congruent to? Angle T. Why? Because what? Oh, no, it has nothing to do with the midpoint. Yes, the one we went over a little while ago. All right angles are congruent. So I know these two angles are congruent. Great, that's one. I need three. Then it says we're supposed to use the definition of midpoint, and it says that W is the midpoint of segment BT. So we're just looking at segment BT. If it helps you, I've said this a couple of times now, draw just that. If W is the midpoint of BT, what has to be true?
Segment BW is congruent to segment W.
Exactly right. Segment BW is congruent to segment WT. By the definition of midpoint. It told you you were going to use the definition of midpoint. That's how I knew what to fill in over here. Then it leads you again, angle OWB. OWB, that's this angle. Is congruent to what angle? I heard one that was right and one that was wrong. IWT. W has to be the middle letter because that's where they are. How do I know that's true? Yeah, it's not a definition. This is vertical angles are congruent. The definition of vertical angles just tells you what they look like. It doesn't tell you that they're congruent to each other. And then triangle BOW is congruent to triangle TIW. How do I know that?
They're both right angles.
Well, they're both right triangles, but to prove triangles congruent, it's always got to be one of those three shortcuts that we've learned. Side, 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 angle, side, or angle, side, angle.
Side, angle, side.
Do we have two sides in this triangle? No. Do we have two angles? Yes. And is the side between the two angles?
Yes.
Yes. So that's angle, side, angle.